Hello everyone. Now in this class we are going to learn about factorization of polynomials. You must have learned about polynomials, the terms related with polynomials in previous classes. पहले तो पढ़े ही होंगे. So we are actually going to recapitulate the ideas and terms related to polynomials before we start understanding the factorization of polynomials. Now, what are the things you have learned? Try to remember. One by one we are going to discuss here. So first of all, we say if there is one term, say 6x, then a single term, or one term, then it is known as a monomial. Okay, right? So now you guess right. If we add one more term, say 2x squared plus 6x, then we have two terms, and this is known as a binomial. And if we add one more term, say a constant term with that, 2x squared plus 6x plus 5, we have three terms, so that's a trinomial. And the terms having two or more terms are termed as polynomials. So it's the number of terms, like here we have 3, here we have 2, here there is only one term. It's the number of terms that decides the name, like monomial, binomial, or a trinomial. Okay, now let's see a more complex polynomial. Let us consider the polynomial fx. You can take gx, rx, whatever you want, but let us say it is fx now. Fx equals to a0 x power n. We go on decreasing the powers of x one by one. So like that we can go on with the terms. Okay, so the second last term will be x power 1, so we don't have to write power. The last term is this. Now fx is the polynomial with the variable x, right? So x is the variable here, and these are known as the coefficients. So a1, a0, a2, an minus 1 are coefficients. And the last term is known as the constant term. Since there is no variable attached with this last term, this is known as constant term. Now here these are all are real numbers. Okay, and n is a non-negative integer. So n is a non-negative integer, then this is the polynomial with a variable x. And now the degree of the polynomial is n. If this first term, if a0 is not equal to 0, then the degree of the polynomial is degree of the polynomial degree of the polynomial is n. Now what happens if the degree of the polynomial is 1? Like in the example, say 2x plus 7. Here the highest power of the variable is 1. So if the degree is 1, then this one is known as linear polynomial. So if the degree is 1, then the polynomial fx is called linear polynomial. If I have a degree with the power 2, say 2x squared plus 3x. So here the degree is 2. It's not quadratic polynomial. Sorry. If the degree is 3, it is known as a cubic polynomial. Like say 5x cubed plus 7. So it's not the number of terms, it's the power of the variable, the highest power of the variable decides the degree, right? So if the degree is 3, it is cubic polynomial, and like degree is 4, it's a biquadratic polynomial. Okay, like 2x power 4 plus 3x cubed plus x, I think. So the highest power is 4, it's a biquadratic polynomial. What if the degree of the polynomial is 0? Like if we say 3, if the degree is 0, as we don't have any variable, so the power of the variable is 0, x power 0 is 1, so we can relate like x power 0 here. So that's actually 3 because x power 0 is 1, so degree is 0. Then this one is known as a constant polynomial. And if we equate fx to 0, like if I say fx equals to 0, that means the polynomial is equals to 0. When we equate it to 0, say a0 x power n plus a1 x power n minus 1, like that. If the polynomial is expressed like this, then this is no more a polynomial, this becomes an equation. So this is a polynomial equation. Now let us try to understand factorization of polynomials with a very simple इंटीग्रल एग्जाम्पल. मैं बहुत ही छोटा सा एक एग्जाम्पल लेने वाला हूँ. Suppose I give you a number 8. Now if I want you to write the factorization of the factorization of 8. So what you are going to write? You're going to write 1 into 8, or you can write 8 into 1. It means the same, right? So that is same. So you can also write 2 into 4 or 4 into 2. You can also write 2 into 2 into 2, right? So that's it. Even if you write 2 into 2 into 2 again, it means the same. So if I ask you only the factors, then 1 is a factor, 2 is a factor, 4 is a factor, 8 is a factor. But when you write like this, 1 into 8, this is called the factorization of 8. 2 into 4, this is another factorization of 8. In the same process, if I take a polynomial. Okay, suppose x squared plus x minus 6. Okay, now if I want to write the factors, you would write after factorizing it, you will get the factorization of this is x squared plus 3x minus 2x minus 6. So finally you'll get x plus 3 into x minus 2. Splitting the middle term, taking common, you get x plus 3 minus 2 x plus 3. So you get x plus 3 into x minus 2. So this is called the factorization of the polynomial. If I want to ask you the factors, then you will write x plus 3 is a factor, then x minus 2 is a factor. These are the factors. And this is the product. The same way, 8 into 1, this is the product. And these are factors. Okay, and this particular way of representing that product is called factorization. So if you write 1 into 8, this is the factorization way, and this one is known as prime factorization, where all the factors are actually prime factors. I hope you understood this factorization part. Let us take another example, like say x square minus 25. So we can easily see it's x plus 5 into x minus 5. So this is the factorization of x squared minus 25. I hope you understood. Both is simple. Try to understand the division algorithm. Okay, so if a polynomial fx is divided by a non-zero polynomial gx, then there exists unique polynomials qx and rx such that fx equals to gx into qx plus rx. Okay, where degree of rx is less than the degree of the divisor, that is gx, or rx can be 0. So we'll come to this point later. First, try to understand this algorithm with the help of simple integral division. Okay, let's take an example like 8. And if I divide 8 by 3, what do I get? 3 into 2, 6, and the remainder is 2. So what if I write in the division algorithm this whole thing, like dividend equals to divisor, that is 3, into quotient plus remainder is 2. So if you now compare with this, you get fx equals to gx into qx plus rx. Fx is the divisor. Sorry.
Sorry. Thank you, idiot.
Fx is the dividend. This is divisor. Gx is divisor. Qx is the quotient. And Rx is remainder. Now coming to the later part, like degree of Rx is always less than the degree of Gx, and or Rx can be 0. Now if suppose 3 is a factor of 8, 3 is not, then the remainder will be 0. So Rx will be 0 when the divisor is a factor of the dividend, right? If the divisor here 3 is not a factor of 8, so we are getting remainder. So remainder is not 0 here. So Rx is 0 when the divisor is a factor of the dividend. So here if you see, the remainder cannot be more than the divisor, because if it is more, you could go one step more here and then 3 into 3 9. So you cannot take it even equal to the divisor. So here in the same manner, the degree of Rx, the remainder, is always less than the degree of Gx. Understood? So the degree of the divisor is always greater than the degree of the remainder, or the remainder can be 0 depending on whether the divisor Gx is a factor of fx or not. It's that simple. Now let us try to understand two more terms, that is value of the polynomial and root of the equation, polynomial equation. So first, value of the polynomial. Okay, this is not an equation. So let us take an example. एक छोटा सा example लेते हैं, जैसे पहले ले चुके हैं. fx equals to x square plus x minus 6. So ये एक polynomial है, ठीक है. So x का कोई एक वैल्यू चूज करते हैं तो fx क्या होगा, ठीक है. So like at x equals to say 2, we have f of x will change, like in place of x I have to write 2. So f2 is the value, right? And how much it comes, that I have to see. So 2 square plus 2 minus 6, that is 6 minus 6, that is 0. So f2 is the value and it is coming to 0. So f2 is the value of the polynomial. What is the polynomial? X square plus x minus 6. तो इस polynomial का 2 पे क्या वैल्यू आ रहा है, that is f2 or 0. f2 is equal to 0. So f2 is the value or 0 is the value. So अगर हम लोग दूसरा एक पॉइंट लेते हैं, एट x equals to -2 लेके देखते हैं. What happens? f of -2 equals to -2 square plus -2 minus 6, that is 4 minus 2, 2 minus 6 minus 4. So f of -2 is the value, and how much is it? -4 is the value. So at x equals to -2, f of -2 is the value. So we can say if fx equals to a x power n plus a1 x power n minus 1. So this is the polynomial. Then f of alpha is value of this polynomial, that is fx, at x equals to alpha. f of alpha is the value. Understood? So whatever the value comes, it is later, it is to be considered later, but f of alpha is the value. Understood? At x equals to alpha. Now moving on to the next part, that is root of the polynomial equation. Now try to focus on this part. This is an equation, right? So an equation looks like fx equals to 0. Let us take this previous example, or we can say x square plus x minus 6 equals to 0. Since fx is this, so this is the equation. Now the value of x at which this polynomial becomes 0 to satisfy the equation. Like I know in the previous example we have seen that at x equals to 2 the value of the polynomial is 0, and hence this will be 0, so that is equal to 0. So 2 is called the root of this equation. Since f of 2 equals to 0, therefore f of 2 is, sorry, not f of 2, therefore 2 is the root of the equation x square plus x minus 6 equals to 0, or here this is fx equals to 0. So you see the value at which the equation, the polynomial value becomes 0. So that value is called the root of the equation. Here f of 2 is the value of the polynomial, and 2 is called the root of the equation since f of 2 is 0. Understood? This is x. Likewise, if the polynomial equation is fx equals to a0 x power n plus a1 x power n minus 1, like that an, then alpha is the root of the polynomial equation if and only if f of alpha equals to 0, or if a alpha power n plus a1 alpha power n minus 1 plus a n equals to 0. Now let us see remainder theorem and factor theorem. पहले remainder theorem को देख लेते हैं. Remainder theorem. Okay. According to the theorem, it says that if a polynomial fx is divided by x minus alpha, then remainder equals to f of alpha. How is that possible? Division algorithm we can see. वहाँ से देख लेते हैं. Division algorithm था fx equals to gx into qx plus rx. In place of gx हम लोग अभी यहाँ पे डिवाइजर किया है x minus alpha. ठीक है? So fx becomes x minus alpha is the divisor into qx plus Rx now becomes C, a constant term. The reason is the degree of Rx is always less than the degree of Gx. Remainder का degree हमेशा Gx divisor से कम होता है. So divisor is already a linear polynomial. So इसका degree अगर 1 है, so the degree of this remainder should be 0. So x power 0, x है ही नहीं. So that is a constant term. So now at x equals to alpha, ठीक है, f of alpha जो है रिमाइंडर है because we are dividing it by x minus alpha. So at x equals to alpha, let us see what it happens. इसको रिमाइंडर बोला जा रहा है. How it is coming to remainder? So x becomes alpha minus alpha, so this is 0 now. Q of alpha, let's see. So we have 0 into q of alpha is 0. Let's see. Hence the remainder is f of alpha is the remainder. This is what the remainder theorem is. So simply we can say अगर x minus alpha से divide करते हैं तो f of alpha is becomes the remainder. ठीक है. And factor theorem just इसी को घुमा करके थोड़ा सा बोलते हैं factor theorem. Okay. If polynomial fx is divided by x minus alpha and a remainder, i.e. f of alpha equals to 0, then x minus alpha is the factor. Remainder equals to 0, right? Okay. Is the factor of fx. Okay. Simply fx equals to gx into qx plus rx. Now if rx is 0, like if I and now since gx is now x minus alpha, fx equals to x minus alpha into qx plus, now this is linear polynomial, so it becomes constant term. Now if this is 0, if the remainder is 0, that means if f of alpha, that is remainder, is 0, our remainder is c equals to 0, then x minus alpha into qx into qx equals to fx, and hence x minus alpha is a factor. Okay. So रिमाइंडर थ्योरम और फैक्टर थ्योरम बहुत ही सिंपल है. रिमाइंडर थ्योरम में रिमाइंडर क्या है वो बता रहा है, एंड फैक्टर थ्योरम में फैक्टर कब होता है ये बता रहा है. सो कोई कंफ्यूजन होना ही नहीं चाहिए. ऐसे तो लोगों को बहुत कंफ्यूजन होती है.
आप तीनों की शक्ल मिलती है, जुड़वा हो? नहीं, हम तीनों तुड़वा है.
So remainder theorem says f of alpha is the remainder And factor theorem says x minus alpha is the factor. When the remainder is 0, that is alpha. F of alpha is 0. So if the remainder is 0, then x minus alpha becomes the factor. That's all. Let us sum up all that we have learned in this class. Firstly, we have learned terms of a polynomial. Then degree of a polynomial. Then types of polynomial, like linear, quadratic, cubic, and biquadratic. Then we have seen value of a polynomial. Then roots of a polynomial equation. Then division algorithm. Remainder theorem. And finally factor theorem. Okay, so don't get confused in any of these topics. If you do feel you are getting confused, go back and see the topics again. Okay, now let us see some examples, see some questions actually from the exercise. Now let us see these questions where it says find the remainder without division. Okay, so we have to use the remainder theorem on dividing fx by x minus 2. Okay, so solution. Now we have fx equals to now using remainder theorem. Okay, here fx is divided by x minus 2. Okay, so x minus alpha. Now f of alpha is the remainder, right? So we have to find out that what is f of 2 is the remainder when fx is divided by x minus 2. Okay, so fx is given, we need to find out f2. So f2 will be 2 into 2 cube minus 7 into 2 square plus 3, it is 2 into 8 minus so we have 19 minus 28, 9. So remainder equals to minus 9. So we found the remainder without using division, but by using remainder theorem. Okay, here also we have the same thing, just this divisor is changed with a bit of different sign. So solution fx equals to 3x cubed plus 7x squared minus 5x plus 1. So using remainder theorem, okay, you need to write this, otherwise writing f of minus 3 will be the remainder is useless. There is no point. So you have to, this is important, using remainder theorem you have to write. So if fx is divided by x plus 3, instead of writing the whole polynomial here, we can simply write fx. Once we write fx equals to this, so x plus 3, then f of minus 3 is the remainder. Therefore f of minus 3 equals to 3 minus 3 cube plus 7 into minus 3 square minus 5 into minus plus 1. So minus 27, 9, minus into minus becomes plus. So this one is minus 27 into 3 minus 81, 63. That is plus 79. That is minus 2. So remainder without division is minus 2. Here's another question. Find the remainder on dividing fx by 2x plus 1. Now in this question we have the polynomial 4x squared plus 5x plus 3, and the divisor is 2x plus 1, which is in the form of ax plus b. So fx equals to 4x squared plus 5x plus 3 remainder theorem. When fx is divided by 2x plus 1, then f of minus 1 by 2, if you equate this equals to 0, so x will be equals to minus 1 by 2. So f of minus 1 by 2 is remainder. So f of minus 1 by 2 equal to 4 into minus 1 by 2 whole square plus 5 into minus 1 by 2 plus 3. That is 4 into 1 by 4 plus minus 5 by 2 plus 3. So that is 1 plus 3, 4 minus 5 by 2, that is 8 minus 5 by 2, 3 by 2. Therefore, remainder equals to 3 by 2. That's all for now. We'll see some more examples from the exercise in the next class. See you in the next class.